In Grade 7, we introduce wheels and axles, cranks, pulleys, gears and cams. In Grade 8, in greater detail, gears, gear ratios, belt and chain drive systems, chain block and bicycle gears. And in Grade 9, we look at gear systems, belt-driven systems with more than one stage, systems where mechanical and or electrical and or pneumatic or hydraulic systems are combined. We will look at some of these in this segment and others in other video lessons. Wheels. Possibly the most important technological invention of all time. The wheel has many forms designed for many different purposes. Here are a few examples of wheels used mainly for fun. We've looked at a shot of truck wheels and wheelbarrow wheels. So that introduces our third simple mechanism, the wheel. I have here the first one we started with. This is the lever. You may be wondering, why am I holding a lever when we're talking about wheels? But in actual fact, the lever is really the foundation for the wheel. If I twirl this lever like a drum majorette, and I'm not a drum majorette, as you can see, you can get the impression that this describes the complete arc of a wheel. I have here a tire from a pram, and I have 4 levers, and as you can see, that these 4 levers form the spokes of the wheel. And in fact, if I put hundreds of these levers in that position, I would in fact have a solid wheel. So a wheel, according to some authorities, is really just a special case of the lever. However, let's keep things simple. We're going to talk about 3 mechanisms. Another specialized version of the wheel is this one. This is called a gear. And again, this is a combination of 2 machines. This is the wheel, but if you look at the edge, it has teeth on it. And teeth, we know, belong to the second simple mechanism, the wedge. So this is a wheel with wedges. I need to put an axle through it before I can do anything with it. So now we have a wheel and axle with teeth, and that is called a gear. Now, gears are designed to work together with other gears, at least in pairs. Gears have to work together to do useful work. In this situation, we've got a large spur gear and a smaller spur gear. Now, one of them will be providing the power and the other will be receiving the power. If I apply force to the smaller one, then the force is transferred from the smaller one to the larger one by the teeth of the gear. So the gear that I put power into is called the driver, and the gear that gets the power is called the driven gear. So this is the driver gear, and this is the driven gear. Some people use the term master and slave, but either of these can be the driver. It just depends on where the force from the motor goes in. Now, I'm playing the part of the motor, so I'm applying force to the smaller gear, so the small gear is the driver, and the large gear is the driven gear. Conversely, I can apply force to the larger one, then the large one is the driver, and the smaller one is being driven, so the smaller one is the driven gear. Now, let's try and compare the speed of rotation. Watch the speed of the 2 yellow marks and compare them. I'm rotating the smaller one at a certain pace, and you'll notice that this is moving more quickly than that one. So we have a speed difference as well as a difference distance. Now, if you think of mechanical advantage, whenever there is a distance difference and a speed difference, there's also a force difference. We will look at a bicycle just now to determine how these force differences work. But if you lose distance or speed, you gain force. So it's clear that if I drive with a certain force here, let's say I turn this with a force of 10 newtons, the force over here is greater, probably around about 20 to 22 newtons.